Hello students, in today's session we shall discuss the effective number of atoms in a unit cell, which is also called as Z effective in solid state lesson. Effective number of atoms means the sum of the contributions of all the portions of the atoms or constituent particles of unit cell is called as Z effective number or rank. The need to calculate the effective number of atoms of a unit cell is generally a crystal is made up of with a combination of many unit cells. As we discussed in the earlier session, unit cell represents a smallest identical portion of the crystal. If you repeat the unit cell, it will develop the entire crystal. The structure of the crystal is equal to the structure of the unit cell. But whenever the crystal is made up of with a different type of the unit cells, the atoms or the particles that present in the unit cell are automatically mutually shared with the other unit cells of the crystal. So in such cases, we need to find out how many number of atoms are actually belongs to a particular unit cell. Type of unit cells we have discussed in the previous session. So in today's session we shall discuss the effective number of atoms and how to calculate this. So the first one is primitive unit cell, which is also called as cubic unit cell or simple cubic unit cell. So in this primitive unit cell, the constituent particles occupy only the corner positions. You can see only the corner positions are occupied by the constituent particles. Only to differentiate the front unit cell with the back unit cell and top unit cells, I had given the different colors to the corner particles, but you remember that all these are identical spheres. So if you observe this particular unit cell, this only black spotted unit cell, imagine this is the one particular sphere or atom. Imagine if all these other parts are not in touch with this particular cube, then this particular sphere entirely belongs to this unit cell only or this cube. So then number of atoms present in this particular cube equals to 8 because 8 corners are there. But whenever this is in touch with the side unit cell, thinking that no other unit cells are present, then this particular atom is shared between the two unit cells. So its contribution towards each unit cell is 1 by 2. Whenever you add 2 more that side, then this corner atom is shared among the 4 unit cells. You can see here number is given 1, 2, 3, 4. This 5, 6, 7, 8 belongs to the top unit cells placed over this unit cell. So here the contribution of this particular atom towards a particular unit cell is only 1/4. And whenever you keep 4 more unit cells over this one, then automatically this particle will be in touch with 8 unit cells. This is 1 black one, here 2 red color one, here 3 this one, here 4, and from top this is 5 green color, 6 yellow, 7 orange, 8 this color. So totally it is shared among the 8 unit cells. Then the contribution of this particular atom towards each unit cell is 1/8 part. Now let us calculate the number of effective number of atoms belongs to the simple cubic unit cell. Total number of atoms at a corner equals to 8. Share of each atom per unit cell means towards each unit cell is how much? 1/8, because this belongs to 1/8, 1/8, 1/8, 1/8, and like this 1/8, 1/8, 1/8. So totally Z effective is equals to totally 8 atoms are there at 8 corners, and each atom contributes only 1/8 part towards a particular unit cell. So 8 into 1 by 8 is equals to 1 atom. So 1 atom per unit cell. So cubic unit cell or simple cubic unit cell is having only 1 atom per unit cell. So now let us discuss the effective number of atoms in body-centered unit cell. So body-centered unit cell is having the atoms located at a corner positions and at the center of the body of the cube. So these are all corner positions. 1, 2, 3, 4, 5, 6, 7, 8 corners. And 1 atom at the center of the body center. So now corner atoms contribution towards any unit cell is only 1/8 part that we had discussed in the simple cubic. So total, let us discuss the total number of atoms in this unit cell. Total number of atoms in body centered unit cell is equals to 8 corner atoms plus 1 body centered atom. Now share of corner atoms. There are 8 corner atoms. Each atom share towards any unit cell is 1/8. So from corner atoms we get only 1 atom. And the share of body centered atom. That means contribution from the body centered atom. You know that when an atom is placed at the center of the body of the cube, automatically it will not be in touch with any other unit cell. Even if you develop the one more unit cell like this, even if you develop it, it will not be in touch with this unit cell or that side any other unit cells. So body centered atom completely belongs to the particular unit cell. So one atom is there. So 1 into 1 means that 100% belongs to the one particular unit cell only. So from this body centered 1 unit cell. So totally 1 atom. From body centered 1 atom. Totally 2 atoms per unit cell. In face centered unit cell, the atoms occupy corner positions, means all the 8 corners, as well as center of each face. There will be 6 faces. This is the left hand side face center, and for the front face center this is the center, and this is the back face center, means for this one completely, and this is the top face center, this face, and this is the bottom face center, and this one, and this is the right hand side face center. So there are 6 faces. So let's try to note down the number of atoms. Total number of atoms equals to 8 corner plus 6 face centered atoms. Now, as we discussed earlier, corner atoms contribution is 1/8 towards any unit cell. So now share from corner atoms equals to 8 into 1/8 equals to 1 atom. And what about the face center? A face is always shared between the two unit cells. See here, this is the face center atom on the right hand side face. Now if you attach one more unit cell to this existed unit cell, then automatically this particular atom is shared between the two unit cells. Means its contribution towards each unit cell is half. 1/2 belongs to this particular side and 1/2 belongs to that particular side. Therefore, share from face-centered atoms. There are 6 face-centered atoms. Each atom contributes only 1/2 towards a particular unit cell, so that it is equals to 3. Total number of atoms 3 plus 1 equals to 4 atoms per unit cell. Next one, edge-centered unit cell. So imagine all the corners and all the center of the edges are occupied by the constituent particles. There are 8 corners are there and edges, 12 edges are there. This is 1, 2, 3, 4 and vertically 5, 6, 7, 8 and this is 9, 10, 11, 12. So totally 20 atoms are there. In this, we know that contribution of the corner atoms is 1/8. Share from corner atoms is equals to 8 into 1/8 equals to 1. Share from edge centers. Each edge is shared among the 4 unit cells. You just take this one as an example. This is the center of the edge of the cube. Now, this initially shared between the 1 unit cell, 2 unit cells from the bottom side, and from the top side, here 3rd unit cell is there, here 4th unit cell is there. Means all these 4 unit cells are met at this edge. So means each of these edge-centered atom contribution towards any particular unit cell is 1/4, such that 12 atoms are there. So 12 into each one contribution is 1/4. It is equals to 3. Total equals to 4 atoms per unit cell. Now let us discuss the number of body diagonals of a unit cell. Here red points represents the atoms of the backside face and here black points represent the atoms located on the corners of the front side face. A diagonal means when two opposite corners are connected, it is called as diagonal. Opposite corners means not along the face here. If you connect along the face, it is called as face diagonal. If you connect along the body center, it is called as the body diagonal. Now I am connecting this red centered atom with the black atom. So this is called as the body diagonal. So how many number of body diagonals are possible? This is the second body diagonal. Third body diagonal and the fourth body diagonal. Therefore, number of body diagonals of a unit cell equals to 4 per unit cell. 4 per unit cell. Now let us discuss the number of face diagonals of a unit cell. If you connect two opposite points or opposite corners along the center of the face, it is called as the face diagonal. Now I am connecting these two opposite faces, these two opposite corner points of the face. Now these two points along the face center. So each face is having the two face centers. Like that, there are 6 faces are there. So 6 into 2 equals to totally 12 per unit cell. So in any unit cell, Z effective can be calculated by using the formula number of corner atoms into 1/8 part plus number of body center atoms into 1 plus number of face center atoms into 1/2, because each face center atom is shared between the two, plus number of edge center atoms into 1/4. So just you substitute number of the atoms. For example, in the case of the body center, face and edge center atoms will not be there, so that you need to consider only these two. In the case of the simple cubic, you have to consider only this one. In the case of the face center, you have to consider this one and this one, you neglect this one. Like this, we can calculate the effective number of atoms present in a particular given unit cell. Hope you like this video. Thank you.